I get to talk to you about refactoring, and honestly, I am super excited to do it. Refactoring is the fastest way that you can elevate your skills and transform your team. I also think it's one of the most overlooked things in Python today. A lot of people either feel like they might have an understanding of refactoring, or they don't really quite practice it. And I believe that it can, like I said, it can transform your team. It can really improve your skills. And I'm excited to give you some tools you can use that you probably haven't even heard of to make a difference. So I'm going to start with a story that I just heard about earlier this year. I got it from this blog post that Alex Everloaf wrote, where he talked about so Alex is a senior level developer, and he transitioned from the team he was on within his company to another team. And in that transition, he started on this code base that had been there for a long time, and his productivity just slowed to a crawl. It wasn't just Alex. Everybody on his team was frustrated. The team, they kind of kept talking about like how hard it was to get things done with all the technical debt that they were experiencing in their project. And if you're unfamiliar with the term technical debt, in just 2 slides, I'll show you exactly what technical debt looks like. But Alex said that leadership did not care about the code quality as long as the stories were delivered on time. Corners were cut and tests were skipped. Does this sound like a project you've been a part of? Because it sounds like the vast majority of mine. Now, while I can relate to this quote, I must say, I don't think that leadership should care about code quality. That is to say, I think leadership wants good code quality, but leadership has so much more on their plate to worry about. They need to make sure that we're working on the right things, that they're talking with the clients, that they're leading us in the right direction and developing us as individuals within the organization. Code quality is in our domain. We should be the ones who care about it. If something goes wrong, then yeah, absolutely, leadership needs to care. And that's exactly what happened in this situation. To explain what was going on, to help to explain what was going on, Alex created this illustration. And essentially what happened is that in order to meet these deadlines, developers would spend their days under complete stress to try to meet these deadlines. And they would try to be implementing features, cutting costs, or cutting corners, doing whatever they can to meet the deadline. And they would not have any time left over to clean things up. And I imagine they probably didn't even have much desire to clean it up either. And so what happened is there's like a bit of maintainability that they didn't get to do that gets pushed into the future, right? So that's what this is showing. In addition, because this maintenance is getting pushed into the future, the total effort of the future starts to grow. And that's what Alex is showing here. This postponing of things and having a total effort grow, that is technical debt. So what did they do about it? Well, the team, the developers, the project leaders, the whole team came together and had an honest conversation about the problem, which I must say needs to be applauded. I don't know about you, but in my life, especially as a developer, the teams I've been on, many times we've just been okay with the status quo. We kind of just accept that this is the way our team is. And it may not be the best, but, we'll just suffer through. It's going to be fine. Maybe I'll look for another job in 6 months. But no, what this team did is say, we need help. Something needs to change. And I really appreciate that. Next, in this process, they got together, had this honest conversation, and the developers requested to stop working altogether, to stop delivering new features in order to clean everything up. The management pushed back on this, and I think rightly so, because they needed people to fix bugs. They needed to make sure the features that they promised would be delivered. And so after negotiating back and forth sometime, they finally decided that every other Friday, they could devote the whole day without meetings to just focus on cleaning things up. And as Alex said, initially, it was hard to defend spending 10% of team bandwidth on cleaning our code. But the payback was huge. So what was the payback? Now, I must say, Alex's team didn't measure any metrics. It's hard as it is to develop metrics that we can measure developer, success and how we do, right? But these are tangible results that the developers felt and experienced. So first off, the code quality improved, which, let's face it, I kind of hope so if that's the goal of this whole exercise, right? Next, outside of those Fridays, they were able to deliver their features faster. Additionally, it nearly eliminated all unnecessary, embarrassingly unnecessary incidents. I loved how Alex said that. And wouldn't that be nice just to eliminate those? Additionally, when developers needed to cut corners to meet deadlines, they were able to make better judgment calls as to how, and then clean it up much quicker. Additionally, they enjoyed their daily work so much more, and they inspired other teams to do the same. So I want to say, I think my next slide is the most important. If you can't get anything else from this talk, I think the next slide is very important. So please pay attention. Most of us are too focused on getting features out the door. But if we spend regular time, even just a small percentage of our time, to improve our code, we can reap huge benefits. And I get this, right? This slide is not just for you, it's for me too, because I feel the rush to get features out. The project I'm working on right now, I've got some leeway, and yet I still feel this pressure to deliver, to get things pushed out. And I would benefit from more time refactoring my code. And just a reminder, earlier this week, back in Monday, James Spadafora told us that Industrial Light and Magic gives developers 25% of their time to address issues, a whole week out of a month, out of 4 weeks. That's impressive. And I think it's Industrial Light and Magic. They've got crazy deadlines and a lot of work to do. So we should do that too. This idea of refactoring has empowered me, and I want to empower you to transform your code. But before I do that, let me introduce myself. My name is Chris May. I'm a Python coach, technical trainer, and I love helping Python developers reach their potential and improve this world. And I'm going to talk a little bit more about that, but I'm just so excited because I proposed this talk because there's a misunderstanding of refactoring that impacted my career. And not just my career, but the teams I've worked on and the developers I interact with now. And I think if we correct that, things could be so much better. So I've talked about refactoring a bit. Let's define it. What is refactoring? Refactoring, the definition of refactoring is improving code without changing its behavior. There are a couple of reasons why we refactor. First, we refactor to make code more understandable, because understandable code has fewer bugs and they're easy to fix those bugs when they happen. Additionally, as we've kind of learned from Alex's team, it can enable us to deliver features faster. Additionally, this world changes. Everything's about change, right? You may have an idea of the direction your project is going, and then a month from now, or maybe even tomorrow, you'll just get a right turn and they'll have a new feature set, a new direction they want to go. Refactoring gives you the ability to make your code flexible to support new directions. As I've done my research about refactoring, I've found that most refactoring advice comes into two categories, and I've decided to label them top-down versus bottom-up. First, we're going to start talking about top-down refactoring. If you have seen any advice about refactoring, chances are it's top-down refactoring. This advice kind of comes from the seminal source, which is the Refactoring book by Martin Fowler. I owe a debt of gratitude, I think we all do, to Martin for curating this book, because essentially in the 90s, well, I think even before the 90s, there for decades, people were trying to figure out, how do we make code better? How do we classify this? How can we repeat this process? And he talked to a lot of people and curated these instructions, these specific instructions of how to make code better. Problem is that at this time, he was writing in Java. He was talking with people who were writing in Java maybe some people in C. So all these rules, these methods, this advice were written with people written with less flexible languages in mind, like I said, Java and C with disposal. So there's some translation that needs to happen if you read these rules. The other interesting thing about these rules is I like to think of them as destinations you can take your code to. Essentially, it's like saying, we don't know about your specific situation, but when we look across all the code that we've worked on over the decades, we can identify certain patterns that can improve code in general. Now, as I say, these are destinations. There are a lot of them. There are over 60 refactoring methods in Martin's book. And that's intimidating. Honestly, when I first learned about refactoring, it was early in my career as a developer, and I wanted to learn about them, but oh my God, there's so many of them. It just was intimidating. It took me years to come back to this. But what's great about them is that it shows what's possible with your code. Like just reading these, you will be exposed to new patterns and opportunities you can use in your own code. But if you want kind of the boiled down version of this, if people have said, like, there are 60 of them, how can we compress this to like one set of rules we can follow? So that's essentially what this is. If you need like a kind of shortcut for these refactoring methods, essentially make sure that tests cover what you want to change, duplicate the code you want to change, adjust it as necessary to cover all the cases, then start rerouting the code to the new code, delete the old code, and test again to make sure everything's working. Each refactoring method has more kind of steps in there, more things to think about. So actually looking at the refactoring methods are a little more helpful, but this is a great way to think about top-down refactoring. So that covers top-down refactoring. Let's talk about bottom-up refactoring. Bottom-up refactoring starts with the code as it is today, and it has a series of small steps you can do to perform on your code, and it actually allows great design patterns to emerge from your code, which is really kind of fascinating when you think about it. Additionally, they're much easier to remember because there's only one of them. And that came from this book, 99 Bottles of Object-Oriented Programming, that was written by Sandy Metz and Katrina Owen. These two women are Ruby developers. They're senior level Ruby developers. They're trainers. They are very experienced in Ruby. And honestly, I love this book. In this book, they came up with the idea of the flocking rules. And this is this refactoring technique I'm going to share with you in just a moment. But I said I owe a debt of gratitude to Martin Fowler. I am just so thankful for Sandy and Katrina for what they did with these rules. Essentially what happened was they were both working on code and they realized this code needed to be refactored. And one of them said, no problem. We just introduced 3 classes here and we're done. And the other one could appreciate their viewpoint, but said, I can't see how we go from here to there. I can appreciate that that's where you think we should go, but I don't understand how you made that connection. And so they realized this was an area where where the world really could benefit from having an understanding of a better way to refactor. How can they teach people to refactor in such a way that they can see the progression? So they worked for 2 years solid to come up with these rules that I'm about to share with you. The key to this is that you want to make your code more alike. And in making it alike, you can abstract away differences. And, well, we'll get to it. I'm going to show you the flocking rules. Don't feel like you need to read them all right now because we're going to go through a sample refactoring. But what I want to talk about is that there are 2 main sections to it. The first is identifying what to work on, which is very helpful. I think this is one of the hardest things, right? If you're looking at code and you want to refactor it, sometimes you don't even know where to start. So that's step 1. The second step, as I kind of mentioned before, is to make those 2 things identical. So let's do a sample refactoring so you can kind of get an idea of how these things work. First, we want to identify what to work on. In doing so, oh, I should say, sorry, I meant to say on the left, obviously, is the flocking rules. On the right is code that generates the first 2 verses of the 12 Days of Christmas, just as an example code to work on. So we want to identify what to work on. We need to find the things that are most alike. In this case, there are 2 verses. That makes it pretty easy. Next, we want to identify the smallest difference between these verses, these items. And in this case, the first lines of the verse are exactly the same except for the 3rd word. So this is what we should work on. Now we want to make them identical. And going forward from this step on, I must say tests are critical. As you'll see later, you'll see why, but I know a lot of us don't have code bases that have great tests. Most of the projects I've worked on throughout my career have not had great tests. But if you go back a couple of days, on Tuesday, Gil Zelberfeld showed us a technique to get some test coverage, which I was really impressed with. Check that out if you don't have any tests. It's early in his talk, he talks about like a tool you can use to create tests that cover what you need to refactor. So now that we have tests in place, first thing we need to do is create a component to resolve the variations. So this is something we'll use to say, as we make things more alike, we want to hand this thing information and say, this is the status of where we're at. Could you give us the value we need back? So we need to create something. This could be a parameter, a function, a class, something that we can talk to, an abstraction we can talk with. But in order to have an abstraction, we need to name it, right? Because we could create like a lambda, but that wouldn't really work so great in this situation. So if we want to define a function, we need to have a name for it. And when when a name isn't obvious to me, I like to go through this exercise where I create a table and I list what needs to be true. So in this case, when the variable verse is 1, this thing needs to return first. When verse is 2, this is second. When it's 7, it needs to be 7th, and so on. So when I look at the relationship between 1 and first, 2 and second, 10 and 10th, the word that comes to my mind is nth. So I say, let's create a function called nth. Let's run our tests to make sure that we typed our code correctly. We don't have any syntax errors, and they pass. Next, we move on to implement the code from one variation. I suggest going with the first verse and returning first. We run our tests, they pass, and we move on. Next, we need to replace one of the differences with a call to the component. And this is where our tests are passed. So we should, let's just go ahead and do it, right? Let's replace first with a call to nth, and we run our tests. It calls the function, it returns first, we're doing well. Next, we can delete any unused code. At this point, we're using all of our code, so we move on to step 5, which is to repeat step 2 until all the differences are eliminated. So we go back up. We can skip step number 1 because we're still working on the same component. So step 2, we need to implement the other code variation. So we can just put in there that number equals 2, return second. We run our tests and they fail. Why is that? This is why tests are so critical, right? Because you can easily just kind of think, all right, I'm doing fine. I'm just going down this line and doing these small little steps. But in this case, we just introduced a parameter into our nth function. And in verse 1, we are not passing in that parameter. So Python's going to say, hey, we need a parameter in here. So instead of changing the code that we've already written, let's continue to change the code we just wrote by adding a default parameter. We run our tests now, they pass. Next, we need to replace the other call or the other difference to a call to the component. So let's go ahead and do that in verse 2. We run our tests, they pass. We can delete any unused code. We're still using all of it. So let's repeat again. This time we can skip for 1 and 2 because all we need to do now is just change the third line to now include verse. We run our tests, they pass. We can delete any unused code, which is now that the first verse is passing in an argument, we can delete the default argument here, and we're done. these two first lines are exactly the same. And so now our code is refactored a little bit. It's more elegant. From here, we can continue going back up to step one and identify another thing we could refactor, such as the gifts. But I wanted to give you an idea of what this was like. I also want to speak to the fact that, like, it's been a few minutes that we've kind of gone through this code. And it may take a few minutes initially as you kind of get used to the flocking rules, but I've got to say, the flocking rules have really impressed me. They have changed the way I've felt about refactoring and really empowered me to do it and to feel much more confident. Part of the reason why is, let's say, like in the middle of this refactoring, that my colleague would have tapped me on the shoulder and said, Chris, we need you. Can you come take care of something? I could walk away and come back. And if somebody was like, Chris, can you just commit your code and push it? My code would still work. At no point, except for that one failing test, would our test fail? Would our code not do what it was supposed to do? In addition, if I were to like come back or get pulled away for some time and I have to come back to my code and try to figure out where did I leave off? The flocking rules are just there to remind me, like, look for the smallest difference. And I could pretty quickly find, hey, I was in the middle of this. Okay, this is where I can pick up. And in a way, they're kind of fractal in nature, which I really appreciate, that they're surprisingly simple and yet can really help out. So that's the flocking rules. I've given you an example of what the flocking rules do, but there was a test I wanted to perform on myself, which was if I could take just some code and try to refactor it in the top-down style and the bottom-up style, what would the difference look like? And I want to show that to you now. This code is a code kata example project that I found online. And this code is an API endpoint that computes prices for ski lift tickets. And, this code is kind of long and has a lot of logic that kind of really makes my brain hurt. I would rather not have to maintain this code. But honestly, the code is not that different from code I've written in my past, and honestly, sometimes when I'm not at my best, right? So I took this code and took the opportunity to do a top-down technique, and this is the code that came out of that. Essentially, what the way I refactored it is the API endpoint now calls this compute price function, which then hands off the calculation of the price to specialized classes. So I have like a ticket class, which is like kind of a base class that has a couple things in it. Then, as you can see, there's a night ticket. So that's one kind of ticket is the night ticket. It has a way to calculate its price. If I scroll down, there's a normal ticket, which also has its way of producing its price. So this, I feel, is improved. It is shorter, and it's nice because, like, if you need to, say, change the way the night ticket costs, exactly where you need to go. So good job, me. Next, I refactored it with the flocking rules. And this is the code that I came up with. And this is all of it. And honestly, I was really surprised by it because I took some time away. So it's not like I was just trying to refactor what I already had. I took some time away, started from scratch, and followed the flocking rules. And honestly, I really like this solution better because if you look at it, it helps you to really understand the business rules. You can see initially that the variety of price first off happens by the kind of ticket that is requested. Secondly, the age. And then thirdly, if you aren't having a night ticket, you can see that there's a variation in price based on the date that the ticket is requested for. And I don't know, I just really appreciate this. It's clearer, I think it's more maintainable, and in some ways it's more elegant. Now, granted, both of these are not like super elegant. They can both be made better. But if you put them side by side, honestly, I have to say these are good for different reasons. I prefer the one on the left, the flocking rules version, for where the app is right now. As I said, it helps you to understand the business logic. I feel like it's a little clearer. But if the business were to start adding new ticket kinds, And especially if there was more complicated logic with tickets, I could see the code migrating more towards the right side. Additionally, I think that if you were to refactor this, you would end up with very different results. And I think part of the reason why I'm interested in the flocking rules versus the top-down method is that the flocking rules, I just followed the rules and it created this result. The top-down method, I locked myself into this structure early on because I noticed there's a lot of data that's surrounding this idea of a ticket. And so I looked at the list and I saw, you know what? I think I need to extract a class here. And I created the class ticket and then created the subclasses from that. So all I have to say is, like, one of the weaknesses of the top-down refactoring methods is that you may choose a path that's not the best for your code. But at the same time, it is still probably improving your code. So that's what refactoring looks like. But what I really want to do is inspire you to refactor. And if you are refactoring these days, I want to inspire you to refactor more. So 3 minutes into his talk at PyCon 2016, effective Python author Brett Slacken said that great programmers write code that makes so much sense, it's easy to understand. However, most developers stop at the point where it works. But great programmers continue on and refactor the code base so that it's easy to understand and that the code is obvious. They do this because it provides a better foundation for the future. Over the long run, it saves you time. As Brett said these words, he put this slide on the screen. And I think he was a little self-deprecating, because he said most of the time when he writes code, he writes it so that he's in that first section where once it's working, he's done. But as he said, the better developers he knows spend more time refactoring, all the way to the point where he says the best programmers he knows spend almost half their time refactoring. Half their time. I mean, that blew my mind. Half their time refactoring. Could you imagine? When I came across this in my research, I said it blew my mind, right? How many times can I say that? But I'm starting to believe that that's a possibility. Because when I spoke to one of the best programmers I've had the ability to talk to, that was Heineck Schlawach. He created adders, so if you use data classes, you can thank him later. But I emailed him and asked him what he thought about refactoring, and he told me, I don't really think of refactoring as a separate thing. It's just the result of having tests and thinking about the design of your code all the time. And listening to him say that, well, reading him say that, I was kind of struck, maybe I'm thinking about programming differently than he is, but I really like his view because I think about authors, great authors. If you have a favorite author or a book that you just love, that every time you read it, you just feel transported, that book was not the first draft of that author. The best writers ruthlessly edit their work, and the best Python developers do too. And just a reminder, if you just spend 10% of your time like Alex did, there are a bunch of benefits you can reap. In particular, I really want to call out the last two. I kind of glossed over them earlier in the presentation, but can you imagine this? If you weren't on Alex's team, I can imagine, I've been there, right? I've been in, lunchrooms or kitchenettes with other teams, developers from other teams, and I can just feel the frustration coming off of them. But then one day, I realized there's a bunch of them hanging around, they're joking, they have smile on their faces. And I'm essentially, there are people in his company that saw enough of a difference. They're like, I want in on that. What's different about you guys? What did you do? And they're like, well, we set aside time to refactor. That's amazing, right? So if you don't know how to refactor, I want to suggest a couple of things you can try. First, ask a Python meetup to do refactoring night. There are Python meetups, user groups all over the world. I'm a organizer of one and in Richmond, Virginia, where I live. But if you want to do a refactoring night, let me know. I'll host one. We'll do it online so you can join wherever you're at. We'll have a great time. Next, talk to your teammates about it, because you'd be surprised. There may be one or two of them that kind of think that they might be interested in it. It might take a little while because, how many people love the idea of refactoring. But take some time, talk to your teammates about it, and see if there's anybody who can help and join you in this process. Next, I suggest you read through a code smell or refactoring method once a week. Set a 10-minute meeting on your calendar, or maybe on a Friday afternoon or a Tuesday morning. Just some time kind of in the margins where you can just relax, read a little bit, and kind of get inspired, get ideas in your mind of what you could do. Finally, practice often. There are refactoring katas online, also known as example code that you can practice through. It's well worth, because initially it's almost like a new skill. Initially, it's going to be hard and intimidating to do anything with code, especially code that you didn't write. But the more you practice, the quicker you're going to get and the more confident you're going to get. Now, I wanted to leave you with some resources, because I know a lot of people like myself, some other developers I work with, they really like to have a book or some kind of resource they can really dig into to learn and to grow. And so for this topic, I wanted to see if there are so many great books. I wanted to recommend like 10. So I thought, is there 3 I can recommend? So the first one is 99 Bottles of Object-Oriented Programming. As I said, Katrina and Sandy are Ruby developers. They wrote the book in Ruby. They created 2 other versions, one in JavaScript and PHP. But Ruby is similar enough to Python that you should be able to translate it without much difficulty. And if you do have difficulty, honestly, reach out to me. I would love to talk to you about it and work with you about it. Yeah, it's a great book, especially it talks about refactoring some, but it's also a great book about design object-oriented objects. Yeah, so I recommend it. Next would be Robust Python. Patrick published this last year, and I've been impressed with, it doesn't really talk about refactoring so much, but it gives you a great, he does a great job of explaining how to write really great Python code and how to make it robust. And so I really like this because it gives you an idea of not necessarily refactoring, but what opportunities, how can you make your code better? And I think that's a crucial part. And then thirdly, I really wanted a great refactoring resource that I could recommend, one where you wouldn't have to do as much translating for Python. And I really had a hard time finding one. So I created one myself, and it's called the Python Refactoring Toolkit. And if you're interested in it, you can go to my website, everydaysuperpowers.dev/toolkit. Essentially, it's all the research I've done, I've put into this thing. If you're familiar with the app called Obsidian, Obsidian is this great app where you load markdown files into it and it links notes. It's a very engaging interface. I wanted to make this resource just to make it easier for people, especially as Python developers who've been left out of the refactoring situation. I wanted to make it easier for you. Well, that's about it for refactoring. If you want to connect to me, please do. I love talking Python. I want to help people enjoy Python more. I said my website is everydaysuperpowers.dev. If you look for me on Twitter, it's @_ Chris May. But more often, I'm on fosstodon.org @_ Chris May as well. Please reach out. I'm on LinkedIn. However you can, reach out to me. So thank you so much. Pam, do we have any questions?
Yes.
Okay.
We have a question that came in. Where do you see the differences in refactoring up front before implementing a new feature, which I practice, and taking some time afterwards to refactor?
Oh man, super great question. I would say, ideally, you should refactor upfront when you're making a change. The reason is, most times, I shouldn't say most times. There's this whole idea in computer science, YAGNI, you ain't gonna need it. The idea is so many times as developers, we're thinking, okay, you know what? I can code in this way and we'll be, in the future, it'll be better this way because we'll be flexible in this way, and this way, and this way. And I know in my own career, I don't know how many times I've been wrong about us making those assumptions. And I've written all this code that never got used. And so if you refactor after the fact, you run into the chance that you're going to write code that you're never going to use. Additionally, if the code is working and it doesn't need to change, then man, that's a great opportunity. You can just leave it alone, and at some point, if there's a bug in there or something, you can refactor it. So I'm a huge fan of refactoring before, like when you come to your code with a new requirement, look to see, like, is it easy to implement that code? And if so, you're golden. If not, you can refactor your code to make it more flexible so you can insert that new functionality, and then you're golden. Both are important, but I would prefer do it ahead of time.